Hello everyone, welcome to Scottish Summit 2021. I'm super excited to be here and I'm so super pumped to give a session on building powerful apps using Microsoft Graph. Before we get started, I'd like to give big huge thank yous and virtual hugs to all the wonderful organizers, volunteers, mentors, and entire community for making this event happen. And big applause to all our sponsors, Group Runner, DQ Global, Proximo 3, Respire, Agilicis, and Hitachi Solution. I would like to remind you to have your phones handy to open your favorite social media and use hashtag Scottish Summit 2021 to follow and engage in all the fun and geeky conversations we will be having within the next few days. So get on there. Who am I? My name is Taerin Pan. Please call me Tay. I'm a Dynamics 365 application specialist at Blackmores here down under in Sydney, Australia. If you'd like to know about me and what I'm currently working on, then please check out my blog and please connect with me through LinkedIn or Twitter. I'd love to hear from you. Our mission today, our objective, is to discuss ways in which we can use Microsoft Graph to build powerful apps on Power Platform in both low and pro code ways. I'm going to touch base on 4 topics in this area. We will uncover how we can use Microsoft Graph with Power Automate Cloud Flows, do a little dive into Lambda Pcf, have some fun with Canvas apps with custom connectors, and wrap it all up with using Microsoft Graph Change Notification. Hope that sounds exciting. 3 useful resources for your Toolbelt. To learn more about the Microsoft Graph, I believe that these are the top 3 places to start. Number 1 is the Microsoft Graph documentation. The team behind this has done an excellent job with the documentation, especially around the versioned API references. Currently, the release of the API is managed in 2 versions, version 1.0 and beta. Often find lots of interesting previews on the beta endpoints, so if you're interested in what is up and coming, then check out that resource. Number 2 is the Microsoft Graph Explorer. This is a purpose-built developer tool that allows you to test the Microsoft Graph API request right from your browser. It handles the authentication process for you, where you can test the API against your own tenant or a sample tenant. It has the option to see what permissions are required for the request and the ability to select and consent to them. The last one, which I've been using a lot, is the Microsoft Graph Postman collection, which you can just clone and import into your own Postman web or desktop client. Super handy to test both the delegated and application permissions request. Quite a comprehensive list of APIs are set up already, so all you have to do is create your own application registration and start playing. So, what is Microsoft Graph and how can it be our secret sauce? Official doc says that the Microsoft Graph is a gateway to data and intelligence in Microsoft 365. But what does that mean? Microsoft Graph provides a unified access to multiple services in Microsoft 365 suite through a single RESTful API endpoint. These services include things like Office 365, Azure AD, Enterprise Mobility and Security, and so on. Why is this relevant to us Power Platform enthusiasts? It's because the business applications and process we build on top of Power Platform can leverage this to allow relevant data to be surfaced to the users to increase their productivity and experiences. Before we get into the fun bits, let's cover this one important topic: security and permissions. Before we can consume Microsoft Graph from any client or application, we must first acquire an access token from the Microsoft Identity Platform. To do this, we need to register an application using the app registration in Azure. Once the app has been registered with the Microsoft Identity Platform, a few of the properties configured and obtained during the registration will be used to request the token. For your app to access data in Microsoft Graph, the user or the administrator must grant it the correct permissions via the consent process. As you can see, there are two types of permissions. Delegated permissions are for those when a physical user is present accessing the application. Application permissions are for apps that run as a background service where there is no user present. Delegated permissions are also known as on behalf of permissions because it's actually the application that is making the request on behalf of the user. Therefore, the effective permission is the least privilege intersection of the delegated permission and the user privilege. Whereas the application permission will be the full level privilege applied and consented by what is set in the app registration. Let's keep this in mind as we discuss the concepts in the demo. Let's jump into demo. What better way to learn than through a good set of requirements, right? Today, I have for you a fictitious scenario which I planned out to encapsulate all the 4 objectives I would like to cover to build powerful apps using Microsoft Graph. So here is a model-driven Power App called Innovation App, with tables to capture workspaces in which the members of the workspace can collaborate on any given topic with their other fellow workspace members. The requirement was to allow the members to collaborate not only from the model-driven app, but the Microsoft Teams as well. So a decision was made to provision a private Microsoft Teams team for each workspace for members to collaborate. The team channels can get filled up with messages pretty fast, as we all know. So they wanted to pin the important team conversation to the relevant workspace topic in the app. This way, they can always find their conversations easily by opening up the topic record without searching it for it in the Teams. The original requirement was to manage the members from the workspace record, which will ultimately add and remove members from the relevant private team. Admin realized that members are sometimes added directly to the teams by the team owners. This will result in unsynchronized list of members in Workspace to what is in Teams. So the administrator requested for an automated way to sync these member changes. So let's begin. Objective number 1, use Microsoft Graph with Power Automate Cloud Flows. So here is our workspace table. We're going to go and create a new workspace and call it Cottage Summit 2021. Save. When this workspace is created, it will trigger a flow to provision a Microsoft Teams for this workspace. Let's go and have a look at that flow. Here we have a couple of provisioning steps. As you can see, I'm using HTTP action to make requests to the Graph API. Here I specify the URI to create the team. And in the request body, I'm specifying that this team is going to be private, and I'm assigning the admin user as the owner of the team. I'm defining the general channel with the tab that leads back to the workspace record URL. We need to configure the authentication for this particular request. Instead of configuring the authentication by choosing this option, the Active Directory OAuth, and configuring the properties individually for each HTTP action, I've decided to use a child flow to acquire the access token upfront so that I can use the access token for multiple HTTP actions and the logic for generating the access token across multiple flows. Let's go look at the generation of the token. So I have the tenant ID, the client ID, and the client secret. I've configured them in the environment variable, and I'm also retrieving the client secret from the Azure Key Vault. Here I have the HTTP action again, which points to the token endpoint. Here I specify the grant type is going to be client credential, and the resource is the graph.microsoft.com. Once the token has been acquired, back in the main flow, I can specify it as a bearer token here. Once the team request is submitted, we get a 202 response back along with the async operation link. We are going to check the operation and see if the team provisioning has been successful. And we'll do this until receive a success as the status result. Once we get the team ID, we will go and update our workspace and update the team ID attributes there. Here we are also going to add another member, actually an owner in this case, to the team, where we'll specify the owner by using the Azure AD object ID that usually gets synced to the user record in Dataverse, and then create the owner there. Once this has been successful, when I come back to the workspace and press refresh, the team ID will be populated along with the member records created. And also in my teams, if I go to the teams, I can see that the workspace for Scottish Summit 2021 team has been created, and the managed team, there is 2 owners been configured, and under the general, I have the channel with the workspace tab that goes back to the workspace record. Something I like to bring to your attention here is that every team that is provisioned is associated with an Azure AD group. So if I pop over to Azure and go to groups, the workspace for Scottish Summit 2021 has been created here, and the object ID is actually the same as the team ID. Back in the workspace record, we're going to add another member to the workspace, my good friend Lee. And in order to detect all the changes to the workspace member records, I have configured a service endpoint to send plugin execution message to the service view. And you can see that in the plugin registration tool, where I have configured the service endpoint registration. We have a dedicated flow to receive all the message from the queue, where it goes and parses the remote execution context of the message. It looks at the message and also the entity to determine where the delegated version of the task should go to. In our case, the parsed pre and post image is sent to a trial flow, which is for adding and removing workspace members. If you want to know more about how to parse remote execution context from service bus, there is a post on my blog for this, so do check it out. And similar to how we added owners to the team, when I come to this add remove workspace members flow, you can see, depending on what the action that we took on the workspace member record, we either remove or add member to the team. And here we are going to add member to the team. So we're first going to check whether if that member is part of the team by using the filter query on the Graph API. And then if the user is not part of the team, we'll add the user to the team, but this time as a member. HTTP Premium Connector is your best friend. Cloudflow was acting as a background service, so we had the application permissions applied. These are the Microsoft Graph API resources that we used and the permissions that was considered. Objective number 2, use Microsoft Graph with Pcf in model app. Now that we have our workspace set up, and then our members want to start discussing certain topics in the workspace, let's go and create a new workspace. And let's ask, how does one watch all the Scottish Summit in one sitting? Interesting question. As you might have noticed, that we have our PCF control here. Let's see in action before we jump into discussing the implementation. First, I need to sign in, and that will automatically sign in as myself. And that will refresh the control to show you the team conversation control. The requirement was that the team members can pin their team conversation along with the topic record for easy access. So here we are going to start a new conversation by choosing the channel. And I'm going to ask, what is the fun? And click new conversation. And this will go off and create the conversation in Teams. And it will save the team message ID so that we can pin this particular message to this record. Let's save that. If I hop over to Teams and go to channel, I'll be able to see that message that I've created here. Now I'm going to ask Ligu, sorry, to jump in to join in the conversation. So in Ligu's team, she can also see the message they have created, and she'll say, I'm going to block out my entire weekend and make a huge pot of coffee. And then in my team, I can see her reply, and I say, I will make cookies. Add a cookie monster to my reply. And when I come into the workspace topic and click refresh, I should see the message conversation and all the replies displayed on this control. To see how this is implemented, let's jump into the Visual Studio code. Here is our Pcf implementation. The most important aspect of the component is the authentication and calling of the Microsoft Graph API. Since this is a Pcf component that's built on React, I'm importing npm package called React AAD MCell and the Microsoft Authentication library, and also the Microsoft Graph JavaScript client library, which acts as a lightweight wrapper around the Microsoft Graph API. If I hop over to app registration, I have configured a new app registration for Team Conversation Pcf. Here I explicitly define the redirect URL to my environment URL for my Dataverse instance. And also I specify that this is going to be an implicit grant flow, and therefore I'm going to check the access token and ID token in the setting. This way, we don't have to expose any sensitive information like the client secret from our client script. In the API permissions, we have these delegated permissions selected and have already given admin consent. Please recall what I said about the affected permission, where in the case if the member is not part of the team group, the control will receive 403 unauthorized response when we try to call the Microsoft Graph API from the control. Entry point to any Pcf control is the index.ts. I'm gathering all the properties for rendering my components here. The one that I'm most interested in is this MCell auth provider. And if I go to the initialization of this provider, I can see that the configuration for this provider is getting set from the environment variable. And that is in JSON format, and it looks like this. It looks familiar, doesn't it? What this provider essentially does is that it goes and acquires the token using the Microsoft Authentication library. Once the provider has been instantiated, this is passed into the Azure AD component. And what this component does internally is that it uses the MCell to check the current authentication state. This way, we can show and hide components depending on the authentication state. For example, in my login control, I can show my sign out and sign in component. Team conversation component is what you see visually. There we have defined the team channel, the text field where we create the new message, and the team messages for the replies. We use React hook, the use effect, to call the graph service to get the teams and the channels and all the relevant information when a certain input changes in the component. The graph service TS is responsible for keeping all the API requests we have in the component, where for each service method, get team, get channels, and new messages. As you can see, we instantiate a authenticated client where we acquire the access token. And using the Microsoft Graph JavaScript client library, we make a request to the Graph API and then retrieve the results that we want. What's really cool about this library is that it gives you the type definition for doing more operations on the API before you make the request. Say, for example, I can specify I want top 10 message replies for this particular request. Quick note, we're using Microsoft Authentication Library, MCL, and these are the npm packages that were involved for this particular PCF control. A disclaimer is that this particular npm package is going to get replaced with this official Azure MCell React npm package, but this is in preview, so it's probably not best to use in production setting. These are the Microsoft Graph API resources that we are calling from our PCF control. Objective 3, use Microsoft Graph with Canvas app as custom connector. So far, we covered how we are going to call Microsoft Graph API through Cloud Flows and from PCF. For the next set of requirements, we also need to have the Canvas app to call the Microsoft Graph API too. As we know, the correct way for us to make API requests from Canvas app is to go through the connectors. There is currently no general connector or even purpose-built connector for what we are trying to achieve. So that means we need to create our own custom connector. If I navigate back to my environment and go to data and select custom connectors, I have one already created using the create from blank option. Let's examine how this is all set up. The purpose of this custom connector is to allow the Canvas app to interact with Microsoft Graph resources around teams, users, and subscriptions. Since our API call for Microsoft Graph API, for the host, we define the graph.microsoft.com as the backend service URL. Like everything else, we need to set the security. And so I have already created an app registration for this particular connector. And if I want to configure the security, I click Edit and choose OAuth 2.0, and I can grab the client ID, the client secret that I have got from registering my app registration, and copy and paste them here. And for the resource URL, we want to specify the graph.microsoft.com as the URL. Once that's done, we can click Update Connector and grab this redirect URL. We come to the Workspace admin app registration, go to the Authentication, and paste the redirect URL here. This app has these API permissions configured and admin consented, and these are all delegated permissions. As a simple example for an action, let's have a look at this definition, get user, and see how we can compose the definition for this particular request. The best way to do this is to go to get user API reference documentation and then grab the example, say the request URL, copy, and come back to our connector and select import from example, select get, paste that in, and import. You can do the same for the response. You can add a default response, go back to the documentation, copy the response payload, and then paste it into the body and import. And once that's done, update your connector. It is best to test the actions once you have created them. So let's go over to the test and then create a new connection. I have already got a connection, so I won't do that. But click on the get user operation, and then let's go and grab Legu's object ID and come back to the connector, paste that, and test the operation. Here we get back the response, and that's simple as that. Now we are going to see how we're going to use this custom connector with the canvas app and the next objective. Quick note, there's no general purpose graph connector. Therefore, we had to create our own custom connector. This connector establishes the connection as the user, so we are using delegated permission. Custom connector that we have created can be used in both Canvas app and Power Automate cloud flows. Objective number 4, use Microsoft Graph with change notifications. To wrap everything up, the last objective is to use Microsoft Graph with change notification. And I can tell you that the change notifications are really cool. Microsoft Graph API uses webhook mechanism to deliver change notification to the application. Useful in the situation where we need to trigger a flow or alert the users of changes in the resources that we are interested in. We don't need to implement a polling strategy here to stay up to date with the latest changes, but we do need to provide a notification URL to where the change notification can be sent. And we can specify this when we create a change notification subscription. Microsoft currently supports subscribing changes on only selected lists of resources. You can see that in this particular documentation. And the one that we are really interested in is the group resource. Remember how I said each team is associated with an Azure AD group? This gets really important for managing the members of the team. The lifecycle of the subscription is something we need to manage as the subscriptions do expire, and the maximum length of the expiration depends on the particular resource. So for group, it is maximum 3 days. So there needs to be a mechanism to automatically renew the subscription or have the ability to manually manage these subscriptions ourselves. We're going to do that through Canvas app. Let's jump back into our environment. And here we have the workspace for admin Canvas app. You can see that we can list all the workspace and the subscription that the workspace currently has. So how do we get here? We have a flow that kicks off the subscription creation process when the team ID on the workspace changes. And that calls a child flow, create group change notification subscription, where you can see that we are using the custom connector we created earlier for creating the subscription. This section takes in several properties, the change type, notification URL, the resource, duration, date time, and client state. Only thing that's confusing here is the client state, and this is for us to check if the change notification came from the valid source. The notification URL for us is the URL that is generated for the HTTP request trigger for the receive group change notification. This one. So this is the tricky part. Before Microsoft Graph creates the subscription, it will make a validation call to the notification URL with the validation token, which you need to return with 200 status code. Once the subscriptions are created, it can be retrieved using the get subscription method from the Canvas app here. And I do want to emphasize that this is using delegated permissions, so we'll only see the subscription that the user has privilege to see. Now let's go back to the requirement. Admin wanted the workspace members and team members always in sync. Since we have change notification subscription to the team group, if the user is added directly from the Azure AD group, we should receive a change notification for that change. So let's go to the group and add a new member. Master book. The change notification takes time to come through. So let's go first and examine what the flow does. Here, once the change request come through, before anything else, we need to send back a response 202. This is so that the Microsoft Graph doesn't keep retrying to send this change notification. There is a timeout of 30 seconds for that to happen, so you better do it at the beginning of your flow. Group change notification comes with the resource data and the payload so that we can look for the member change there. So I have a sample one here that I can show you. So the notification comes with this particular member being added to the group. Going back to the flow, if the member changes for deletion, we can go and delete the workspace member record. And if it's for the addition, we can create the workspace member record as you. Here we check whether if the user exists and the workspace exists. And if that is the case, we go and create the workspace member. And if I come back to the workspace and hit refresh, I should see Nesta Rook added as the workspace member. In the Workspace for Admin app, we have the ability to renew and delete the subscription from here as well. Let's go and delete the subscription that we have just created. And so now we have no active subscription. And if I remove Nesta from our group again, Nesta, we won't get no change notification received for this. From the workspace, we can see that there is a conflict between the member list in the workspace and the team member list. And you can see that by clicking on the information where it says that workspace members are not in sync. And here we can see that Nesta Rook is actually been removed from the team members manually. We can also create subscription from outside Powerapps, say from Postman, using a different application registration for this. So in unusual circumstances, even though I am the creator for this particular one, I won't be able to see this. But this permission that I have set in the app registration, subscription.read.all, will allow me to see those subscriptions. Quick note, we have covered webhook mechanism to deliver change notification to the apps. We also covered the lifecycle of managing the subscriptions and using Cloudflare to receive change notifications and use Canvas app to manage the subscriptions using the custom connector. I hope that gave you some idea on how to build powerful apps using Microsoft Graph. Thank you so much for joining me for this session. It was a real pleasure to be here. Please reach out to me through Twitter, LinkedIn, or email me at karim.han@live.com. And I'll be posting more topics like this on my blog, so please follow me there as well. Please show great support to our amazing speakers who will be presenting this week and on the main event in the next few days. So please go promote the event using the hashtag Scottish Summit 2021. Catch you later. Bye.